Hello friends, the question is like this. By using the properties of definite integrals, evaluate the integral modulus of x plus 2 dx from the limits -5 to 5. So to solve this question, first of all we consider this definite integral. Okay. And we see that we have been given a modulus function to integrate. So whenever we have been given a modulus function to integrate, we first of all simplify the modulus function for the limits which we have been given, and then we are going to integrate. Okay, so first of all we see that x plus 2 is greater than or equal to 0 when x is greater than -2. This means that the value given inside the modulus is positive for x is equal to for all the values of x greater than or equal to -2. Okay, so if the value of x is going to lie between -2 to infinity, it would be positive. Okay, so this conversely means that the value of x plus 2 will be negative for all the values which are less than -2. For example, if x is equal to -3, so this value will become negative. Okay. So to simplify this modulus function, I write this, that modulus of x plus 2 is equal to this value. Before explaining what I have done here, I like to put some light on this modulus function. Modulus function, as most of you must be knowing, always gives us a positive value. So for the values x greater than -2, its value will remain unchanged because it is going to be positive. Okay, because when x is greater than or equal to -2, the value of x plus 2 will be positive, so we write that modulus of x plus 2 is equal to x plus 2 in this interval. Okay, but for the interval, for the values which are less than -2, x plus 2 will become negative. If you place x as -3, you are going to get -1. But when we place a minus sign outside the bracket, okay, this minus sign which is written outside the bracket would make this a positive value. So this is how we get modulus of x plus 2 as equal to minus of x plus 2 when x is less than -2. Okay, so we are going to write this definite integral as a sum of two definite integrals, and then we are going to solve it to get the answer. So for this we are going to apply this property, fx dx from a to b. So this property is only available when the function is continuous in the interval a to b. Okay, now modulus function is, as we have been given in this case, is continuous for all real numbers. For all real values, this function is continuous, but it is non-differentiable. It is non-differentiable for the value that is x is equal to -2. It is not differentiable for this value. So we are not considering the non-differentiability of this function. We are only considering the continuity. So the function is continuous for all the values. That is, for all the real numbers, this function is continuous. So we can apply this property. And this property states that this can be written as two separate integrals from the limits a to c and c to b, where c is the number which is going to lie between a and b. It is going to lie between the interval a and b. So we write this definite integral from the limit -5 to 5 as equal to minus of x plus 2 from the limit -5 to 2, because for all the values less than -2, this modulus function is equal to minus of x plus 2. Okay, and we have to integrate from -5, so we have taken the lower limit as -5 and the upper limit we take -2, and further we write this as equal to integration of x plus 2 from the limit -2 to 5. Okay, so this is what we have done. Now we are going to integrate it. Integration is quite simple. This will be x square upon 2. This will be 2x, and minus sign you can multiply inside the bracket to obtain minus x square upon 2 minus 2x from the limit minus 5 to minus 2, and similarly this will be equal to x square upon 2 plus 2x from the limit minus 2 to 5. Now we have to solve this. On solving, we have to place the upper limit subtracted from the lower limit, upper limit subtracted from the lower limit. So I'm going to get this as minus of minus 2 whole square upon 2 minus 2 into minus 2 subtracted from the value which we are going to obtain on placing the low limit in this expression, that is minus of minus 5 whole square upon 2 minus 2 into minus 5 plus 5 square upon 2 plus 2 into 5, placing 5 in this and placing minus 2 in this, that is minus 2 whole square upon 2 plus 2 into minus 2. Okay, so we are going to get this as equal to 2 times minus 2 into minus 2 whole square upon 2 into minus 2 into minus 2. Let me explain how we obtain this. On multiplying minus sign inside this bracket, we are going to get both these terms as identical. Both these terms become identical, so I write it like this. Okay, and next what I get here, this is going to become 25 upon 2 minus minus plus. Okay, and this will become plus 10, and this minus sign outside the bracket gives us minus 10, and this term 25 upon 2 plus 10, this 10 and 10 cancels out, and this becomes 25 upon 2 will become 25. This is going to become 2 minus 2, and this is going to become plus 4. So this bracket is going to become actually 2 into 2 4 and plus 25, so this will be equal to 29, which is my required answer. So this is how I'm going to solve this question. To watch more of these super videos and for the latest update, subscribe and like the videos on these YouTube channels, HSK Shiksha and Maths Help by HSK. Thank you.